Way, hello year 12. I'm just going to pause my other computer. I've already done the register, so we can crack straight on with paper 3 now. It's always good for me to figure out the delay time as well. There we go. Okay, right, I'm going to crack straight on with the paper. I'm going to finish off that paper 3 because of that ambiguous question at the end, which is rather interesting. Right, let's go straight on to that. Okay, so this is where we left off. I'll share my screen. Share screen, go, that one, and then hide, and then this one. Yeah, right. I'm just typing on the chat. Hey, guys. Right. Okay, so last question on the paper. Won't take very long to do. Obtaining pure, dry crystals of an inorganic salt from its solution is an important process in practical chemistry. Agreed. Another important process is obtaining pure, dry, organic liquids from a mixture of liquids. Both processes start by heating the mixtures. State the process. State the purpose of heating the salt solution. Right. So, guys, this is GCSE. Do you remember this? Do you remember doing salt extraction from GCSE? The preparation of salts. And you guys learned 2 methods at GCSE. One for making soluble salts and one for making insoluble salts. And this one here is related, that is related to IGCSE, GCSE salt preps, salt prep. And in this case, they're talking about a soluble one. Yeah, so this is actually relatively straightforward, actually, this part. So why do we heat the solution? Do you remember in the preparation of the soluble salt, what we did is we heated the solution, until 80% of the water has evaporated. 80% of water has become gaseous. Yeah, has left and become gaseous. And then do you remember this whole, you test it using a glass rod and crystals form on the glass rod? So the reason for heating the salt solution is to produce a saturated solution. Yeah, to produce a saturated solution. Yeah. You could also say to make it more concentrated, I guess, but that's really the answer. I definitely want to see the mark scheme. I made such a mess of this paper 3. It was a really tough paper, and I'll mark that in a minute. Next, name the process for separating 2 miscible liquids. Right, hang on a sec. The word miscible means they dissolve in each other. So if you had this picture, that there would be immiscible. Immiscible. Yeah. And immiscible means that they don't mix. Yeah. You will form 2 distinct layers, with the more dense being at the bottom. But if they are miscible, yeah, miscible, the miscible ones are going to form a single mixture, no layers. What that means is you're going to have to use fractional distillation. Yeah. So to separate 2 liquids that are miscible, fractional distillation. Distillation. Sorry, that was the distillation song. Fractional distillation is used, not us used, is used to separate. And it is based, it then says, stating how it works. The 2 liquids have different boiling points. This is IGCSE. These are relatively easy. Yeah. The liquids have different boiling points. The liquids have different boiling points. I'm also aware that different boiling points. I'm also aware that it's only 2 marks. If that was 3 marks, different boiling points. If that was 3 marks, I would have added an extension saying the liquid with the lowest boiling point leaves first. Yeah. Liquid with lowest. That's going to be the 3rd mark. It would have probably been worth 3, and then they'd cut it. Hence the big gap, huge space. The liquid with the lowest with the lowest BPT, I wouldn't write BPT in an exam, by the way. They don't know what that means. Lowest boiling point will boil away first. Boil away first. Yeah. That could have even been 4 marks if they'd given you it as an example. The example, of course, the normal example of miscible liquids would be something like ethanol and water. Ethanol and water are miscible. The ethanol leaves first, having a boiling point of 79 degrees Celsius, and water then leaves at 100, so the ethanol leaves first. Yeah. Next, another step is to remove the impurities from both the crystals and the liquid by washing. Okay, inorganic crystals are usually washed with distilled water. State the 2 conditions needing to minimize loss of product. Right, this is organic. This is in organic prep. Right, so if you were, let's say, for example, we decide to make an organic liquid, or in fact, we're making an organic crystal. Yeah, so it's a solid. So we need to make an organic solid. So let's say we were going to make soap. Let's do that as the example, since Dixon is doing it as his project. Let's say we're going to produce soap production. Yeah, we're going to take vegetable oil, veg oil, which is an organic liquid. Yeah, and we're going to add it to sodium hydroxide. Now, we're probably not going to add the sodium hydroxide as a solid. That's going to cause horrible lumpy messes. We're going to add it to a sodium hydroxide solution. And what I'm going to get out at the end is going to be soap, and it's going to be a solid. Would everyone agree with this statement? So if you then wanted to purify, to clean your soap at the end, what do you think? What do you think we're going to be washing away? We're going to be washing away sodium hydroxide, and we're going to be washing away any leftover vegetable oil. Well, we know that once we've got our soap bar, once we've got our soap bar, there's our soap bar. Would everyone agree that if you now wash, I'm going to move that. If we now take any organic solid, I have no idea. Why does it do that? I honestly don't know. So strange. If we were to wash this now with water, there's our tap, and we were going to wash this with water, would everyone agree that you're going to wash away some of the soap? We're going to lose our soap. Well, imagine if you only made 1 gram of it. Well, you don't want to lose, you want to lose as little as possible, hence minimize loss of product. So first thing we're going to use is we're going to use the minimum amount. We're going to use, minimum amount of water. Yeah, we're going to use the minimum amount of water that we need to wash it with. And we're also going to wash it with really cold water. We would actually use ice cold water, but we'd use cold water. I'm going to put that in brackets, just in bold. Cold water. That's going to be the mark. Yeah. Now, the reason why we use cold water, if that was a 4-mark question and they asked you to explain it, you're going to say because cold water reduces solubility, so you lose less. So less dissolves and washes away. Yeah. During the preparation of an organic liquid such as a haloalkane, the crude product often contains acid impurities. Yes, it does. The reason being is a lot of the time, if we're going to make a haloalkane in an organic prep, let's say we want to turn ethanol. Let's say we want to turn ethanol into 1-chloroethane. Let's say we want to do this in synthesis. Yeah, we've already seen this, I think, in one of the papers. To do this, you would use concentrated HCl or PCl5. Well, PCl5 will form phosphoric acid as a byproduct anyway, or POCl, and POCl reacts with water to form phosphoric acid anyway. So we're going to have at the end of it, if we started off with ethanol, yeah, and then we add our conc acid, add our HCl, we're going to be adding that one in excess. Yeah, to make sure all the ethanol is converted. Well, what that means is we're going to have chloroethane left behind, and we're going to have leftover HCl. How do you now neutralize that? Well, you need to make sure that you neutralize it with a base, but you cannot. Why can't you add sodium hydroxide? Year 12, put on the chat. Why can't you now add sodium hydroxide to neutralize the excess acid? Why not? Impress me. Go on, is anyone going to say anything on the chat? Come on, guys. Come on. Oh, no one's going to say anything. Don't know why. Anyway, the reason why is because sodium hydroxide produces OH minus ions in water. OH minus ions in water. OH minus ions act as, wouldn't it react with the haloalkane? Yes, yes, thank you. OH minus acts as nucleophile. Nucleophile acts as nucleophile, reacting with haloalkane. Yeah, absolutely right. And we would turn it back into the alcohol, reacting with haloalkane. Right, so what choice do we now have to neutralize an acid? We need a weak elimination. No, it would be dilute, Winkit. It wouldn't go through an elimination. You'd have to use concentrated hot ethanolic. There's no ethanol left. Can he see this chat? Yes, I can. Yeah, it's all working. Oh, hang on. Have I missed a question? Where's my writing gone? Have I deleted all my writing? Don't know. No, I'm up here. Name a suitable solution. Sodium, hydrogen, carbonate. Name. Oh, that would have been an easy miss. Sodium, hydrogen, carbonate solution. You could use sodium carbonate, but you wouldn't. Sodium, hydrogen, carbonate solution. There you go. There's my answer. It's a weak base, yeah, and therefore won't react with the halo. Next, name the process used to separate solid crystals from a solution. Filtration. It's not hard. If you were doing this in organic, it would be vacuum filtration. That's A2. Name the piece of apparatus used to separate two immiscible liquids. Right, the piece of apparatus is called a separating funnel. Separating funnel. I'll show you what one of those now looks like. They're kind of cool things. They look like pears. Separating funnel. Images. There it is. Isn't that cool? So that's a separating funnel. There you go. So separating funnels are used for separating. Oh, can he see the chart? C2 is the question without a mark scheme. Yes, it is. Yeah, I think so. Yeah. So the first mark is for saying separating funnel. State the property other than immiscibility that makes this separation possible. Right. The other one is difference in density. The liquids have different densities. So one will float on top of the other. That's the answer. We're done. Yeah. Third mark would be more dense liquid at bottom. They often like to give you data for this. These questions, again, very common questions. They've asked you to draw it on many occasions. Let's draw a separating funnel. And that then goes to a tap. There you go. I don't like the fact that it's going through it, but so there's a separating funnel. And what you realize is the two liquids will sit in here. The more dense, more dense at the bottom. Missed a letter, nice. More dense at the bottom, less dense at the top. And this is where you have to know one density. You have to know one. That water is 1 gram per centimeter cubed. Shouldn't do that at A level. 1 gram per centimeter cubed. Not per centimeter, per centimeter cubed is its density. That's the density of water. Have to know that one, folks. Yeah. So if they gave you something like vegetable oil, veg oil, which has a density of about 0.83, does depend on the density of the oil, of course. Well, actually, maybe it's higher. I don't know. Veg oil is actually, I think it's actually a bit higher. It depends on the vegetable oil. But vegetable oil tends to float. Yeah, it's less, 0.83 grams per centimeter cubed. So we now know that that one there is smaller than that one. So the veg oil therefore goes on top. How could you improve? Another question to add here. How can you improve separation in a separating funnel? How could you improve separation? Answer, add sodium chloride to the water. Add salt to the water. What that will do is an explanation, EXP, NaCl increases, because it dissolves in the water, it increases the density of water layer, improving separation. You get less of a blurry line. Whenever you actually get this, the actual line is not solid. It's kind of, this is where I need a, hang on, I've got an idea. It's kind of blurry, like this. Yeah, like that. That would be the separation layer. This is because at that layer, the two liquids are forming what's called an emulsion. Yeah, immiscible liquids, when you shake them, they form a hazy, what look cloudy solution. Yeah, and you get this blurry layer. And it's really nice to be able to then realize that you can actually reduce the thickness of that by adding salt. If you add salt, you increase separation, improve separation, more distinct or clear, more distinct boundary layer. Isn't that called boundary layer? Great question, very common. Anyway, but nice and easy. Liquids have different densities. Both inorganic crystals and organic liquids are usually dried. State how crystals are dried. Well, that's really stupid. You could use a drying oven. You could use paper towels. You could use a drying agent. Oh, right, that's stupid, you see, because they've lumped inorganic and organic together. Well, if you were going to dry inorganic, you'd use a drying oven. If you were doing an organic liquid, you can't because it's a liquid. Stupid. State how crystals, that's solid. So we're going to say a drying oven. Drying oven. Or, yeah, no, I'm going to put a drying oven or paper towel. And put drying oven. That's my choice. Name a suitable substance for drying organic liquids. You need a inorganic crystals are usually dried. State how they are dried. Yeah, I'm going to choose that. Could you use filter paper? Yes, probably. Be interesting to see what the mark scheme says. Name a suitable substance. Oh, maybe the mark scheme isn't there. Name a suitable substance for drying organic substances, and name calcium chloride. Calcium chloride is my That there is a desiccant. Desiccant. It's otherwise known as a common name, drying agent. Yeah, and you use that in the liquid. Yeah. And that brings us to the end of the paper. I do want to see that mark scheme. Blimey, I don't even know where the mark scheme is. I had to traipse through the internet to find it. Paper 3. Check all my answers now, folks. Right. These are the ones at the end. This is the one that people were saying that marks were missing, and that's fine. We can solve that one. Okay. Dried in a desiccator, allow in an oven, but ignore, e.g. heat in an oven, warm in an oven, reject any, drying agent. Okay, just to check. Concentrate the solution, so crystals on to produce a saturated solution, there's mine. Fractional distillation, the liquids have different boiling temperatures. Small amount of minimum quantity of water, ice cold. I like it, ice, I'll add that into my next time. Sodium hydrogen carbonate. Filtration, I like it. Dry between filter paper or in a desiccator. Oh, blimey, I spelled desiccator wrong. Double C apparently. Desiccator, interesting. Paper towel, ignore, leave it to cool in an oven. Addition of anhydrous. Reject and have I missed a trick there? Does the brackets mean it needs to be there? Addition of calcium chloride. I think I get it, don't I? They could use paper towel. They would allow that. Filter paper. Yeah, they'd probably allow filter paper. Yeah, I'd give you a filter paper. Right. That brings us to the end of the paper, folks. That's great. Right, guys, I'm going to leave you be for the rest of the lesson. You can work on your projects. If you could input your data, that would be fantastic. And you need to start the next ones, folks. I know that I'm going to share my screen again, just really briefly. Yeah, just to quickly remind you, that data needs filling in. You need to start June 2018. It's on the Save My Exams website. But guys, it has been great to see you as always. I hope you have a great rest of your day. And yeah, see you later, guys.